Hey, welcome back everyone. This is Rinlin. Here I'm going to create another educational video once again here on Tuesday afternoon at brilliant.org. Continue with this chapter technology, deepen your knowledge of how things work. And we're still continuing this relevant chapter from previous session, how technology works, as I'm displaying with a pointer here. So I'll click on it. Yes, we're currently still at level 2 progress devices and hardware. And as you can see, we're currently standing in this chapter frequency and phase. That's the kind of exercise we're gonna do for today's session. So I'll click start to begin. Wait for the content to get loaded. I'm about to speak. Right, welcome back. Frequency and phase. Another property of waves is frequency, which measures how rapidly the wave oscillates. So frequency, it starts from this peak to another top peak that follows. So it keeps repeating and oscillating. Yes, frequency is measured in hertz, which is just the number of wave cycles per second. Now we can simply adjust the frequency to see how it affects the wave from period time to time. You see, as frequency increase, wavelength from one to another decreases over time. So many frequencies and shorter wavelength from one to another, like that. And reversing will increase wavelength and reduce number of frequency, number of oscillations. So the reverse process. That's how you just discovered from this chapter in the very beginning. Right. Click continue for the next one. Yes, what happens to the crest of the wave as frequency increases? And the crest means like height of amplitude. Yes, of course. It gets closer together. That's right. As an alternative to changing amplitude, we can also encode data by changing the wave's frequency. So like what I just previously demonstrated as that frequency change and oscillation. So we can change this frequency like this. If I click on it, yes. If I alt click to 1 instead of 0, so frequency will probably double, twice as many. Too many frequencies and get closer together, very short wavelength, very smaller gaps compared to the normal oscillation. Right, continue. Wait for a moment. Well, binary signal code encoded in this wave. That's pretty simple. Only the left two sections of this oscillatory signal had doubled as much, so number should be this. Wait, 1100. Let's check it. Yup, that is correct. So why for reasoning? I'm gonna scroll down here. Higher frequency here represents 1, so the 4 sections of this wave represents 1100. Alternatively, you could also use the higher frequency for O instead, so 0011 is also a valid solution. Two different answers which are definitely mathematically valid here. Right, you just discovered the same format of this answer given to the previous one I've already demonstrated to you. Right, continue for the next one. This technique is much less prone to errors than changing amplitude and is commonly used for digital radio and voice calls. Continue. However, when we need to send a lot of data with limited bandwidth, changing frequency is worse than changing amplitude. Luckily, there's a third wave property we can change to encode information. Are these two waves exactly the same? Saying like they got same amplitude, same wavelength, like number of frequency also constant. So I assume yes, they're exactly the same. So I'll click this option. While these waves have the same amplitude and frequency, they aren't exactly the same. Oh dear, my assumption was wrong again. This is because the position of the waves in any given instance or the wave's phase was different. Phase position is different from one to another. Many assume like same amplitude, same wavelength, constant frequency might be the same characteristics of one another, but it's actually not. Continue. In this wave, the reference phase shown with a dotted line corresponds to 0, while the other phase corresponds to 1. Right, toggle the buttons to switch phase. So if I click this, like this, 1, so that will shift. So you just see shifting 0 and 1 give the same format. So if I click all to turn to 1, 1, 1, 1, they will all shift in different phases from one position to another. So the trend just follows the same characteristics. Right, continue here. Wait, what binary signal could be encoded in this wave? Oh yes, obviously only two sectors change were around here or there, so these two, I assume. Let's check. Yup, that's correct. So why for reasoning? I'll scroll down. The reference phase here represents O, and the outward phase is 1, so the four sections of this wave represent O1, O1. Alternatively, you could also use the reference phase as 1 instead. Similar technique works. So 1010 is also a valid solution, so two alternative answers are possible. No need to determine that too much complications. Continue. Now, changing phase is more complicated to do, but less prone to errors than changing amplitude, and additionally it allows higher data rates than changing frequency. Any Bluetooth devices in your home are likely to be using this technique. So like when you initially discover what technology we are using at home nowadays, like in environmental techniques, so this is just the proof. Right, continue. Right, changing amplitude, frequency, or phase can all be used to send the same information. You click like amplitude, this. I'm just telling you like amplitude change into each phase will all shift like how many sector it might change in according to a factor. Frequency here, they all just change from one position to another. Finally, phase here. Like this, and so on. Alright, just the brief overview of summary how they shift from one position to another. So, like kind of a recap. Continue. Oh, alright, there it is. These three waveforms are supposed to send in the same message, but one of them contains an error. Oh. Which wave contains an error and is sending a different message than the other two? This amplitude, frequency, phase, frequency. I probably think yes, this amplitude is an error not different to the other. This one must be, yeah. Let's check. Yup, that's correct. Why for reasoning again? Yes. As I mentioned, the error in this wave is varying amplitude, which encodes O111. Other two waves are O110 here. if I click on frequency, no, can I click it? No. Phase also, no, I cannot click on this as well. No, this is already what I just click on it, so I can no longer access this anymore. Right. Anyway, let's move on. Continue. Yes, this is kind of a summary statement in this final content of the lesson. Digital data can be transmitted wirelessly by modulating electromagnetic waves. Ones and zeros may be represented by two different values of amplitude, frequency, or phase. The receiver can convert the wave back to the strings of ones and zeros, only these two, which in turn could represent songs, videos, websites, or any other kind of digital media. Brief summary overview of what we've learned in the wireless communication, the electromagnetic waves transmission in terms of oscillation, kind of important key characteristics that you have to consider whenever we analyze these in terms of mathematical and physical theories. All right, we've done this lesson exercise, so I'll click finish to conclude it. You wait. Right, lesson complete. After attempting a few practice questions with checking answers, I've gained total of here 55 XP, experience points this time around. Continue. Oh. My streak extended to 5 days in a row, right? So starting from Friday in the first place and 5 consecutive days means I've done another exercise here on Tuesday. That's kind of simple. Already explained to you in the previous videos. Continue. It's better in the app. Over 95% of mobile learners prefer it. Well, even this QR code scan below to download now, I don't necessarily need to. My mobile app will not let me download and access these contents. No, I prefer an PC app. Continue. Level up your learning with premium. No, no, no. Kind of premium users only. I'm only accessing free contents in every characteristic, every circumstance. So remind me later. Wait. There we have it. We've successfully completed the devices and hardware level 2 chapter exercise called frequency and phase, kind of additional features that you've learned in this technology sectors in every aspect of physics and environmental understandings. All right, so that's it for all of this educational video that I've created today so far to all of you. So thank you very much for watching, and if you do so like it, then don't forget to add a like as always and subscribe to my YouTube channel for other related educational videos and anything else you can access for any enjoyable videos, I mean. But I'll still come back to this educational YouTube video recordings for more recordings channels in the future. Right. That's it guys, everyone, for today. I'll see you in the next video, guys. Take care. Cheers. Bye.